Welcome back, I'm Jim with Cyber-Recon, and today we're diving further into Security Plus certification exam preparation. Today we're talking about Domain 1.4, Subdomain 1.4, penetration testing concepts. So let's jump into the slides and see what's going on in the world of PowerPoint. So 1.4 is part of Domain 1, compare and contrast types of attacks. This is penetration testing concepts. We're going to go from the first part to the last part. We're going to cover everything in this subdomain in this presentation. So as we jump off, first of all, we want our definition. And this is from NIST. As you know, if you've been hanging around with me, you know I want to use NIST whenever I can because it gives us a common lexicon that's been vetted by a good group of folks who work for the National Institute of Standards and Technology. So we'll use their definition whenever we can. So they say pen testing is security testing which evaluators mimic real-world attacks in an attempt to identify ways to circumvent the security features of an application, system, or network. Penetration testing often involves issuing real attacks on real systems and data using the same tools and techniques used by actual attackers, to quote NIST. And across the bottom you see the steps that you need to know for Security Plus. So these are not the same steps if you're going for Certified Ethical Hacker or if you're going for one of the other certifications. They're not exactly the same, and they're definitely not in the same order. So you will need to know these for the Security Plus exam. You'll need to know some of these, but in a different order for other certification exams. So what Security Plus talks about is active reconnaissance, passive reconnaissance, pivot, initial exploitation, persistence, and then escalation of privileges. I don't agree those in the right order, but I am not going to argue with CompTIA because they're the ones, they're going to issue you your certification. So we will talk about these in this order and cover the stuff you need to know about each of them to be able to successfully pass your certification. Starting with active reconnaissance. The intent of active reconnaissance, or reconnaissance in general, is to obtain understanding of systems and components. What the attacker wants to do with reconnaissance is paint a picture of what the environment of the system looks like. What components is it comprised of? How is it configured? How are things connected? Are there pieces that are exposed? Can I find out about the people that are running the system? Can I find out who the administrators are? Can I find out where the help desk is located? What can I find out about the system? So this is just doing recon, right? If we watch war movies or we've been in the military, we know recon, we're trying to figure out where the enemy is. And in this case, we're looking for the penetration testers' enemies, so to speak, right? So if we think about this, there's a group of people defending the network, and the penetration tester is trying to exploit the system. And we'll figure out the little differences between vulnerability testing and penetration testing at the end of the slide deck. So the thing you need to know about active reconnaissance is that the attacker, the pen tester, will be interacting with systems and components. They will be sending commands across the network. They will be interacting with servers and network devices and workstations and anything that they can kind of get a hold of and try to see what they can find out. The big thing about active reconnaissance, it can be observed. If the defenders are looking and they're monitoring their systems like they should be, active reconnaissance should be detected in some cases, right? At some level, I should say. This may alert the defenders. So when you're doing active reconnaissance, you need to be ready to jump in and start your penetration testing activities because the clock could be starting. They could be initiating their protocols to defend the network. So maybe you've exploited a system, or maybe you're doing what we call like an nmap scan, a network mapper scan of the network. When you kick that off, it's probably, it should, in a good network, alert the defenders that something is going on. There's another side of this. There's a side called passive reconnaissance. And this does not provide active information about systems or networks in scope. The attacker is not interacting directly with systems and components of the system, and this maximizes use of open source intelligence. We talked about open source intelligence already, so we're not going to go down that road again. But we're going to do things like internet searches. We're going to look at DNS records. We're going to find out everything we can find about that organization. Maybe this is where we find out what's the number for the help desk. What's the CSO's name? What's the CIO's name? What's the CEO's name? All this information we're going to use for our attack. And depending on the scope of our attack, we may use social engineering. So we may need to know those people's names to try to pull off a social engineering attack. Or we may just look at DNS records to figure out, where's their mail server at? Do they have a web presence? Where's the web presence at? Where are all these things? And this is just, it's passive. It's not interacting with the system. It's going to be impossible for the defender to know you're doing this. So it may be driving around and looking at the headquarters building. It may be, determining if the garbage is being left out on the street, that kind of thing. So it's passive. It's not actively interacting with the system. So those are two things you need to know about active and passive reconnaissance. Keep those two separated, you'll be good to go. Pivot. This is when the attacker exploits their first system. So it could be a printer, could be a network device, server, workstation, something. It's that first device that was compromised, and then that attacker is going to use that machine to pivot or change focus and try to penetrate further into the system or the network. So they may use that system to start a new set of scans. They may start doing more active reconnaissance from that device's point of view. And then they can use that device to jump off and launch another attack on another system, maybe deeper in the system, deeper in the network, or another system that has elevated privileges. So we're going to pivot from, we're going to land, we're going to exploit an initial box, an initial system, and then we're going to pivot, maybe we're going to do some more reconnaissance, and then we're going to try to attack other systems. And now we're coming, instead of from outside the network, now we're coming from inside the network. So maybe we're doing a remote desktop to that system, and then we're going to use that system. First of all, a lot of times we've got to get our tools on there. So one of the things we don't want to do as a defender, as a blue teamer, is to have attack tools on any of our internal network systems. This way, when the attacker lands and pivots, they're going to have to bring their tools with them. So if we make sure there's no tools available inside the network, that makes it harder for the attacker. So what the attacker does, they'll land on this first box, they'll exploit the first box, and then they'll have to bring their tools in. And then they'll try to leapfrog into the next system. So we're going to pivot from that system, and now we're inside the network now. It makes it a little easier, and a lot of times we can launch additional types of exploits because now we're on the network. The initial exploitation is just kind of what we're talking about prior to the pivot. This is when the attacker uses vulnerabilities to compromise and exploit a device in scope. And I'm always going to say in scope because when we're doing a penetration test, we have to have those lines drawn. We have to say, this is in scope, this is out of scope. We're going to get a license from probably the CSO and the CEO or CIO to go in and run this penetration test. So we need to know what we can and can't do. Sometimes we can't use denial of service attacks. Sometimes we can't maybe harvest passwords. There are certain things we're going to be able to do and we're not going to be able to do. And we're going to have a document, rules of engagement normally, that's going to tell us what we can and can't do. So we want to make sure we're attacking a device in scope, inside our perimeters that we're allowed to attack. And that's that initial compromise. We're going to use vulnerabilities to compromise that device. And this really demonstrates that a vulnerability is present and exploitable on that box. It doesn't normally achieve the objective of the pen test. So the pen test can have a bigger objective. And this initial exploitation is just saying, I can get on this one box. Maybe it's a Windows box or a Linux box. I've landed on the box. I've exploited the box. Now I'm there. Now I'm probably going to launch a pivot and continue the penetration test. Normally, the penetration test is on a bigger system. So when we exploit that box or that series of boxes, computers, I say box, that just means that's part of the chain we're going through. So this initial exploitation is your first, it's putting your foot in the door. It's keeping the blue team from being able to shut the door. And we're going to use that to achieve the bigger goal of the pen test. So we're going to use this initial exploitation normally to pivot and move further in the network. So that's just our initial drop. We've used a vulnerability to compromise and exploit a device in scope. Persistence is just staying in the network. Once we get in there, we want to stay there. There should be two goals in persistence, right? Avoid detection from the defender and remain inside the system as long as possible. And that's probably your penetration test is going to be defined by a time frame. So your rules of engagement will say maybe from May 1 through May 30th or less time or more time depending on the system. This is when you're going to be running your penetration test. Persistence means as soon as you get on the network, as soon as you compromise that first box, you can stay on the network the entire length of the scope, right? The entire time period you're allotted, you want to stay on there the whole time. For the nation states and the APTs we talk about, the advanced persistent threat, they want to stay on your network forever. They don't ever want to be detected. And what they'll do is they'll seek multiple places in the system to hide out and stay there. So if you find them on a Linux box, they may be hiding out on a Windows box. They may be hiding out on a printer. They may be hiding out on a SCADA device or an Internet of Things device like your thermostat. I know it's crazy. It sounds crazy, but attackers can attack things like automated thermostats and hide out there. In case that Windows box is detected and it's cleaned off, they can still come back into the network from another device. So normally a pen tester will do it. They'll save several places in the network where they've got an access point. It won't just be one place. So if that system is cleaned, it won't just be that one system that's been compromised. That's why they're going to pivot. They're going to move around the network. They're going to exploit as many boxes as they can, and they're going to try to maintain persistence. So if you detect that they're on a Windows box, you clean that all up. They may also be on the printer. They may also be on a Linux box. They also may be on a server. And as you clean them up, they just reinfect. They keep moving around the network because they have that persistence. The ultimate goal is you never find them, right? You never detect that the attacker's there, and they just remain on the system. That's true for a pen tester. That's true for an APT. So as a defender, you want to make sure you're looking for things that don't look normal and have your systems hardened, right? And then escalation of privileges. Normally when we land on that box, we land on a computer, you're going to have a lower level of permissions or rights. So normally when you exploit a computer, the exploit normally gives the attacker the level of permissions of the person that's normally using that computer or the person that's using the computer currently. And if you're set up right, if your network is set up correctly, that means they'll have normal user rights. They're not going to have escalated rights. They're not going to have admin rights. They're not going to have any of that. So what the attacker has got to do is either pivot to a machine that has higher levels of permission or escalate their permissions, or their privilege, right? And we saw this in Pass the Hash. If I can land on a box where that person has local admin rights and it's vulnerable to pass the hash, I may be able to find out if there's domain credentials on that box in LSASS and then use that to maybe create my own account or elevate that end user's account that I have permissions to. So the goal of escalation of privilege is to take an account maybe you've already compromised and elevate its privileges, or maybe even just create a brand new account and elevate that privileges. And we want to get as many privileges as we can on the network because that's going to prove what the attacker can do in the penetration test. And that's what we're trying to do. We're trying to prove vulnerabilities are present on the network, right? So normally a lower level account is going to have weaker controls, and we can use that lower level account hopefully to escalate to a higher level account. And I say that, normally if we look at a control like password length, a normal user may have a password length of 8 characters, while an administrator may have a password length of 15 characters. So maybe it's going to be easier to break that password of the normal user and then maybe elevate the privileges. So things we need to think about is escalation of privilege once we've got inside the network. So we talked about, I've been using the term boxes a lot, right? We exploit this box or that box. A lot of times that's how we think about the computer. It's just a box, right? So there's 3 types of attacks we'll talk about using black box, white box, and gray box. So we start with black box. That's where the attacker has little knowledge about the system or software. It's normally from an external attacker's point of view. And we kind of think of it as there's data going into a box, there's data coming out of the box. We don't know what's going on in the middle. We don't have any information of what the components are of the system or the software. And from the attacker's point of view, the attacker has to figure all that out. Normally this type of penetration test we're going to say the attacker is taking the point of view of the external attacker. And a lot of times with web applications, we're going to do black box testing, but that's not a hard and fast rule. White box testing, some folks call this clear box testing. I've never heard that, but know that in case it comes up. The attacker knows pretty much everything about the system. They know the internal workings of the systems. They're aware of the bugs and vulnerabilities that are in the system. They have detailed knowledge about the system or application. And a lot of times we do this just to speed things up. We go into the test with the knowledge of the system. So know this, that a black box test, little or no knowledge about the system. That's why it's highlighted there. A white box test, detailed knowledge about the system or application. Good thing to know about those two things. Keep them straight in your head. You'll probably need to know that. And as you could probably expect, the gray box attack is a combination of the white box and the black box. The attacker has some information about the system, but some information is unknown. And this is just, we kind of want to speed the test up. And a lot of the times when we're talking about gray, white, and black box testing, generally it goes back to the amount of time the penetration tester has to conduct the engagement. So that may be just because of resources. That may be because the organization doesn't have funding to do a black box test. It's going to be a lot more expensive for a black box test than a white box test. So maybe we're going to do something in the middle. Maybe we're going to do gray box. We'll give a little bit of information. Maybe we'll give IP ranges. Maybe we'll give types of systems to the attacker, and then they'll have to figure out everything else. So gray box is just kind of a mix of white and black box. And then the big thing we've been kind of alluding to as we've been talking is what is the difference between penetration testing and vulnerability scanning. So vulnerability scanning a lot of times is done with an automated tool, and it's going to determine if there's a vulnerability on the system. That's what vulnerability scanning does. It's going to scan the system. It's going to look at the software. It's going to look at the folders. It's going to say, are the correct patches applied? Is this system configured correctly? The penetration test goes kind of a step further. It takes that vulnerability and determines, can this system actually be exploited through that vulnerability? So the vulnerability scanning determines if there's a vulnerability on the system. The penetration test can contain that component of vulnerability scanning. So maybe the penetration tester has to scan the system as well. But they're going to take it a step further. They're going to say, can this vulnerability that we found on the system actually be exploited? And if it is exploited, what is the cause? What happens to the system? What's the repercussions of that vulnerability being exploited? So that's that's it. Let me check here. Vulnerability. That's it. We've made it through this subdomain. So we made it through 1.4. That's what you need to know for the Security Plus exam. Know the different phases that the penetration tester is going to do. Know what a penetration test is. Know the difference between black box, white box, gray box, and know the difference between vulnerability scanning and penetration testing. You'll be solid. You'll have a good solid foundation for what you need to know for the Security Plus exam. As always, I'm Jim with Cyber-Recon. Please hit the bell to be notified when new content comes out. Share with your friends. And as always, we'd appreciate you. Drop the comments below. Let me know what you guys are doing, how you're progressing in your security career, and how we can help you get to the next point. Until next time, be careful out there. We'll see you next time.